Today we're going to talk about inequalities in two triangles. Gentlemen, quiet down. Okay, inequalities in two triangles, section 5.6. Yesterday we talked about inequalities in one triangle. Now remember, yesterday we said if I had a triangle here, something like this. If, let's say this was my biggest angle, what's opposite the biggest angle? The biggest side. That's what we talked about yesterday. Today now we're going to talk about inequalities in two triangles. So what are the relationships between two triangles? So to help us with that, we're going to talk about what is the Hinge Theorem. The Hinge Theorem states that if two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, then the included angle that is larger has the longer third side across from it. So what that means here is, for example, we know these sides are congruent. If angle K is greater than angle J, what do you know about the side opposite of K? It's going to be bigger than HJ. So for example, let me use some meter sticks here to represent this. So example here, down at the bottom, it shows that 3 is the same side as 3, and they share the side in the middle. Well, which one's going to be bigger, 38 or 47? 47. So that means that PQ is going to be bigger than SR. Okay, that's what that represents. Correct. So let's look at a couple problems here.
Sorry.
Number 1, TV and XY. So notice here they have the same segments. I have 11, 11, 10, 10. So I'm looking at 81 and 88. Which one's bigger, 81 or 88?
88.
88. So I would say that TV is less than XY. And I'd write that as an inequality. Now let's look at on the flip side here. It wants me to talk about angles G and angle L. Well, I have 5, 5, 7, 7. So they're the same lengths. Now I'm looking at the opposite. I have 5 and 4. Which one's bigger, G or L? So I'd say angle G is greater than angle L.
This is so easy.
Now number 3, pay attention here. It says AB and AD. So I want to find AB and AD. I'm going to compare these. Notice they have the same sides. This angle is 90. This angle is 100. Which one's going to be bigger, Chris?
100.
So which one's bigger, AB or AD?
AB.
So AB is greater than AD. Now pay attention here. Listen up. Okay, let's reference this triangle. Would BD be a straight line?
No.
Why is it not a straight line? Great.
Because 90 equals 180.
This would have to be 90 degrees here. So recognize this is not a straight line, because some people are like, well, it's got to be 90 degrees, so it's got to be the same. No, it's 100 degrees. That's like if I take a line here and I kind of angle it back a little bit. That's what's going on. All right, so again, yeah, recognize number 3, it's not a straight line. 4, I have angle FHE and I have angle HFG. So which one's going to be bigger, FHE or HFG? So I would say, yeah, FHE is less than angle HFG. Okay, so we can use that representation there. Nice job. Take a couple seconds, try these 3 on your own. All right, number 5, Anderson, compare them for me. Angle K and angle M.
M is greater than K.
Yep, I would say angle K is less than angle M. And why is that? Let's look at it here. Notice, KJ goes to here. LN is going to be a longer segment. LN is longer than LJ because J is between LN, which means that that side's longer. So M has to be a greater angle. Number 6, let's look at AB and DE. Becca, what's the answer going to be there? AB is less than DE.
Good job.
Nice job. And last one, number 7, QR and ST. Chris, what are you thinking?
ST less than QR.
Yep, so QR is greater than ST. Nice job. Okay, again, we're comparing the angles or sides there. Next part we're going to talk about now is using that same concept to find a range of numbers. So for example, I want to compare these side lengths in the triangles. So we're using the same concepts here. Now we're going to find the range of possible values that x could be. So if I look here, I have the angles 66 and 71. So as you look at it, which one's going to be bigger, MP or QR? QR. So we would say like MP is less than QR. Does everybody agree with that? Great. Now I'm going to take the segment lengths and actually write that out. So I'm going to say 3x minus 6 is less than 24. So 3x minus 6 is less than 24. And I'm going to solve for x.
Yeah, you had to have math for this.
So I take 3x minus 6 is less than 24. Add 6 to both sides. 3x is less than 30. Divide by 3. You get x is less than 10.
That's your answer?
That's half of my answer. Because it can't be anything less than 10. In order for a side to exist, what's it have to be greater than? Has to be greater than 0. So I also just have to set that inequality greater than 0. So I say 3x minus 6 is greater than 0. I add 6 to the other side. 3x is greater than 6. Divide by 3. And I say x is greater than 2. That gets me my compound inequality of two statements. So the one time you got to set it less than the other triangle. And the second inequality, you have to set it greater than 0, because it has to be greater than 0 for it to exist. So let's look at number 8 here. I want to find a range of values for x. As I look at it, I have two angles here, 46 and 51. Okay, how would I set up that first inequality, Jake O'Connor? Yep, so 2x plus 4 is less than 18. And now I solve for x. How would I solve for x, Jake? Subtract 4. 2x is less than 14, right? Divide by 2. X is less than 7. And then for this side, in order to exist, Jake, what's that to be greater than? So I'm going to say 2x plus 4 is greater than 0. And how would I solve that, Jake? Subtract 4. 2x is greater than negative 4. Divide by 2, and I get x is greater than negative 2. Now, some people earlier are like, well, that doesn't make sense because you can't have a negative. Remember, this is just what x is. So, for example, what's a negative that's greater than negative 2? Negative 1, right? Let's plug negative 1 in here. If I plug negative 1 in, what's 2 times negative 1? Negative 2 plus 4?
2.
Oh, my side length would be 2. Okay, so notice, it's not my side length that's negative, it's just x that is negative, so that is okay. All right? 9, kind of a different problem here. Now I want to do the angles. Well, if I look at my angle here.
So we can just leave it like that, or just x?
Yep.
Oh, I thought we had to put it,
I mean, you could put it as negative 2 is less than x, which is less than 7.
yeah, that's how we
You could do it that way. Yep. How would I set up number 9? Claire, how would you set that up? The first one. 3x minus 9 is less than 54. Now I solve for x. What do I do to solve for x, Claire? Plus 9. 3x is less than 63. Divide by 3, and I get x is less than 21. And then in order for this side to exist, Brock, what's it have to be greater than? So I'd say 3x minus 9 is greater than 0.
Add 9.
Add 9 to the other side.
Divide by 3.
Divide by 3, and I get x is greater than 3. So that means my x has to be anywhere from 3 to 21. So 4, 5, 6, 7, all those possible answers. Take a couple seconds, try the next two on your own. All right, let's walk through number 10. I'm going to set the first inequality. Trent, give me the first inequality. How'd you set it up? 2x minus 6 less than 108. When you do that, what do you get for x is less than?
X is less than 93.
X less than 57? Because don't you add 6 and divide by 2? So x is less than 57. And then I need to set up a second inequality. Katie, how would that second inequality be?
X is less than 2x minus 6 is less than 0.
Greater than 0.
Greater than 0.
And then when I do that, I get x is greater than what? 3. So if x is less than 57 and x is greater than 3.
You always put the second one over 0.
Yep. Because that has to exist, so it has to be greater than 0. 11. How would I set up 11? Read. Give me the first one. How would I set it up?
5x plus 3 is less than 38.
Less than 38. Okay, and when you do that, you get x is less than what?
7.
Then how would I set up the second one, Caden? Yep.
Yeah, 5x plus 3 is greater than 0.
Great. So I subtract 3 and divide by 5. I'm going to get a fraction. What's the fraction, Anderson?
3/5.
X is greater than negative 3/5.
What? You just told
I
me
asked,
nothing.
I asked you if it was
Yeah,
negative
you
3/5, and you said no.
I didn't hear you say negative. Sorry. Yeah, negative. I think you said 3/4. Maybe that's what I thought it was. Yeah, 3/5. Yep. Negative 3/4. Nice job. Must have heard you. Very good. Now a couple things here. I feel like we got a pretty good job of this. I'm just going to demonstrate a couple more on the next page. Okay. So 12 we would set up again. I want to look at 13 real fast. Okay. Let's look at 13. Notice they give me two expressions. Right? Which one's got to be smaller?
3x minus 5.
So I would say 3x minus 5 is less than x plus 12, right?
Yep.
And now I would solve. So in order to solve that, I'd subtract x to the other side.
2x minus 5.
Add 5 to the right side. So I get 2x is less than 17. Or x is less than 17 over 2. Right? Okay, good. So that's one half of the problem. The second half, though. Which one do I set greater than 0? Doesn't matter.
No, not really.
It does matter.
Oh wait, yeah, 3x minus 5 is less than 0.
I would
Or
set
greater than 0.
3x minus 5 is greater than 0. Why would I pick that one? Because it's the smaller one. If the bigger one's greater than 0, that's great, but then the smaller one can still be less than 0. That doesn't work. So you always need to set the smaller one greater than 0. So I would say 3x minus 5 is greater than 0. Add 5, divide by 3. I get x is greater than 5/3. Now I have my two answers there. So recognize when I have two statements, that's fine. I just need to make sure I put the smaller one greater than 0 there. All right, nice work. Here's your assignment.